We're looking at number 22 on page 427 that we worked on yesterday in class and then last night. This particular problem you're proving or determining rather if the quadrilateral with the given endpoints here is a rectangle or not, specifically using the slope formula for number 22. Okay, so if you did not have this sketched out, then go ahead and take a second here and just sketch this rectangle on a coordinate plane like what I have here. And I mentioned to you yesterday, there's no need in actually going through here and doing, all right, 1, 2, 3, 4, 5, 6, 1, 2, and plotting your point. Just kind of eyeball it and get a general visualization of what your quadrilateral looks like. That way we know where the vertices are in relation to one another and which segments make up my sides and things of that nature. Okay, so if we need to, let's take a minute to pause and get this sketched out. Alright, so since I'm using the slope formula, my plan of attack here is going to be that I want to find the slope of line segment WX and compare that to the slope of line segment ZY. And I want these slopes to be the same in order to make these two parallel. Okay, that's before I can say that this is a rectangle, I first have to say that it's a parallelogram. Okay, so I'm comparing the slopes of these two to make sure they're the same, and then I'm going to do the same thing with the slope of WZ and XY. And now if I find these slopes and they're not the same, that means that my opposite sides are not parallel, which means it's not a parallelogram, which means it's not a rectangle. So I'm starting at this point, finding all of these slopes. So we'll start, doesn't matter, let's just do WX first. Okay, so label your points here, and the slope of WX is equal to 5 minus 4 over 5 minus a negative 2, okay, which is 5 plus 2. So my slope of WX is 1 over 7. So now I want to find the slope of ZY and compare that to the slope of WX, and I want those to be the same. So we'll label our points here going from left to right again. And I've got the slope of ZY is equal to Y2 minus Y1 over X2 minus X1. Negative 2 plus 3 is 1, 6 plus 1 is 7. Okay, so I know that these two lines are parallel, so that's a good start. So now I'm going to go to my left and right sides and make sure that they're parallel. And I'm going to leave these slopes up here because I'm going to use them again in just a second. So finding the slope of WZ, we've got X1, Y1 up top here, X2, Y2, and then we've got Y2 minus Y1 over X2 minus X1. This would be a negative 7 over positive 1. And then lastly, I want to find the slope from X to Y and hope that it's the same as this, proving that these two lines are parallel, making my quadrilateral a parallelogram. So the slope of XY is equal to, we'll label our points, X1, Y1, X2, Y2, and plug into our formula. Negative 2, or Y2 minus Y1 over X2 minus X1, and again I get negative 7 over 1. So I know that the quadrilateral is at least a parallelogram at this point. So now what I'm going to attempt to do is prove that it's a rectangle. Okay, well, a rectangle is a parallelogram that has 4 right angles. Okay, that's something that's true about a rectangle that's not necessarily true about all parallelograms. So if I can prove that I have right angles, then I can prove that this is a rectangle. Okay, but I don't necessarily need to prove all 4 of these angles are 90 degrees. If I can prove that this one is 90 degrees, then by the transitive property, so to speak, I also know that this angle is 90 degrees. Okay? If I have 2 parallel lines with a line that's intersecting them, and one of those intersections forms a 90-degree angle, then the other intersection also forms a 90-degree angle, which is what I would have going on here. Okay, so if I can prove this one 90 degrees, that means this one is. And if I can prove this one 90 degrees, that means that this one is as well. All right, so how do I use slope to make this determination? Well, I know that the slope of perpendicular lines are opposite reciprocals, which means they have a product of -1. So this is the information I'm going to use to help me determine whether or not I have 90-degree angles here. So which slopes am I looking at? And I want to compare the slope of this line WZ to the slope of this line ZY. So let me come down here and write that. Slope of WZ and slope of ZY. That's one of the comparisons I'm going to make. And then I also want to compare the slope of XY to the slope of YZ. Okay, so slope of XY, slope of YZ. Okay, so I've got all my slopes written down. Slope of WX was 1/7. Slope of ZY was, the slope of WZ was -7. And the slope of ZY was 1/7. And then the slope of XY was -7. The slope of YZ, which is the same thing as ZY, was 1/7. All right, and when I multiply these two things together, if I get a product of -1, then that means they are opposite reciprocals. Okay? And there I do get my product of -1. And again, here I've got -7 times 1/7. So I get a product of -1. So I first proved that it was a parallelogram by finding the slopes of opposite sides to be the same. And then I found it to be a rectangle by proving that the slopes of consecutive sides were opposite reciprocals. For number 24, we're doing the same thing, except now we're specifically using the distance formula to determine whether or not my quadrilateral is a rectangle. But I still want to first prove that it's a parallelogram, and then if it's a parallelogram, then I can go about proving that it's a rectangle. So in this case, to prove it's a parallelogram using the distance formula, I want to find the distance from Q to T and compare that to the distance from R to S and make sure that those are the same, proving that my opposite sides are congruent. Okay, so distance of QT and then distance of RS. And I want those to be congruent to one another. And just for the sake of time here, we're not going to go through the process of actually plugging this stuff into the distance formula. Okay, but you do end up with a distance of √45 for both of those. So I know that I know that those sides are congruent. Then I want to find the distance from QR and compare that to the distance from T to S. and show that these two sides are also congruent. So my distance of QR and distance of TS need to be the same. And here I end up with a distance of root 20 for both of those. So this information is what allows me to say that this quadrilateral is a parallelogram. Now that I know it's a parallelogram, I'm going to compare the diagonals. So a parallelogram that has congruent diagonals is more specifically a rectangle. So now I'm comparing the distance of QS to the distance of TR. And if I know that those two distances are congruent, then I can say that my parallelogram here is in fact a rectangle. So the distance of QS ends up being root 65, and then the distance of TR also ends up being root 65. So first I prove that it's a parallelogram by proving the opposite sides congruent, and then once I know that it's a parallelogram, I prove that it's a rectangle by showing that the diagonals are congruent as well. 23 and 25, those we did not talk about because you can find the answers in the book. So if you look up your answers and compare it to what you have in your work and you're still confused on 23 and 25, then just send me a message and we'll try to get that figured out together. All right, for 26 through 31, we're determining what the angle measures are, given that the measure of angle 2 was 40 degrees. And the first one here, 26, the measure of angle 1 is fairly simple. This is complementary to angle 2. Okay, so I subtract 40 from 90 to get my 50 degrees for number 26. Number 27 is based on something that we haven't talked a whole lot about, other than when we first started talking about the characteristics of rectangles. And one of those characteristics is that your diagonals are going to create two congruent triangles. Okay, so I've got my green triangle here, and I've got a 90-degree angle. Then I've got angle 4 that's included in my triangle, and angle 2, which I know is 40 degrees. Okay, then I also have, let's do red for my other one. And I've got this triangle that's going to be congruent to the green one. And then I have, again, a 90-degree angle here, angle 6 that makes up part of this triangle, and angle 7. Okay, so I've got my 90-degree angle here in the green, and angle 2 is right above it, and it's 40 degrees. Okay, so my red triangle is going to follow that same pattern. Since my triangles are congruent, their angle measures are going to be congruent and in the same locations. So here's my 90-degree angle for my red triangle. I go straight above that to angle 7 and find that it is also 40 degrees. Okay, and then once I find that one, everything else is kind of fill in the blank, so to speak. I've got 50 here. I've got 40 for angle 7. The measure of angle 3 is alternate interior to angle 2. So it's going to be congruent to angle 2, and it's 40 degrees. The measure of angle 5 is, well, we'll come back to the measure of angle 5 because it's going to be easier to find that once we've found some others.